Yeah, that's plot here. So it's really probing basically the earliest structures we know in the universe.
When you look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
We have been seeing this object already in the very early data we obtained nearly 2 years ago. And I think the surprising thing was that it's actually very bright. And so our initial reaction was that, well, it cannot be that distant because it's too bright. And so we took better data, and in particular, we also took spectroscopy. And we could clearly see that, no, that galaxy, that this yellow blob here, is really this most distant galaxy that we have ever seen.
Something in the early universe isn't following the script. The equations don't line up. And scientists are openly admitting they don't yet understand why. Deep field images are now overflowing with unfamiliar objects, thousands of them. They don't resemble known galaxies. They don't behave like stars. Researchers stare at the data, compare notes, argue late into the night, and still can't say with confidence what they're looking at. More troubling still, Webb has now pushed past a boundary we'd never crossed before, peering into eras once thought completely inaccessible. What it found there left seasoned astronomers stunned. Most experts agree on one thing. The universe is roughly 13.8 billion years old. That timeline has been foundational. But the structures appearing in these images strain that framework to the breaking point. They seem too mature, too complex, too massive to exist so early. And that's why the conversation has taken a dramatic turn. Several Nobel Prize-winning physicists are now suggesting that the early universe may have operated under rules we don't yet understand. Some are going further, entertaining ideas that once bordered on heresy. What if the universe didn't begin the way we think it did? What if what we call the early universe isn't the beginning at all, but something else entirely? At the heart of the tension is the standard cosmological model, the one built on cold dark matter and dark energy. According to that framework, many of these newly observed objects simply shouldn't exist. They appear far too massive, packed with an impossible number of stars for their age. There hasn't been enough time. There isn't enough normal matter. To make structures that large, nearly all available material would have needed to collapse into them, and that defies basic physics. So what exactly has the Webb telescope uncovered at the furthest edge of what we can observe? And why are researchers saying this could upend everything? To understand that, we need to step back. For nearly a century, scientists have known that galaxies aren't standing still. Since the late 1920s, we've observed them drifting apart, not because they're flying through space, but because space itself is stretching. There's no central point, no privileged location. Wherever you are in the universe, everything else appears to be moving away from you. It's as if every observer stands at the center of expansion, and it doesn't stop there. That expansion is speeding up. Distant galaxies aren't just receding, they're accelerating away faster than closer ones. Now imagine Earth sitting right here, and Webb gazing outward. In every direction, space pulls galaxies away from us. The farther they are, the faster they retreat. Eventually, you reach a boundary where galaxies appear to recede at the speed of light. This boundary is known as the Hubble sphere. Beyond it, space expands so rapidly that galaxies seem to move away even faster than light itself. At first, that sounds like a hard limit. Common sense says light from beyond that region should never reach us. But reality once again refuses to be simple. We can still see beyond that boundary because the boundary itself is moving. As space accelerates, the Hubble sphere grows, allowing ancient light, emitted long ago under very different conditions, to finally reach our telescopes. And that's how Webb is showing us things we were never sure we'd be able to see. Not just distant galaxies, but clues that the universe, at its deepest level, may be far stranger, older, and less understood than we ever imagined. As space keeps stretching, it gradually pulls ever more distant galaxies into our line of sight, even ones racing away from us faster than light itself. But this visibility doesn't go on forever. There's a hard boundary to what we can observe, a cosmic horizon scientists call the observable universe. From edge to edge, it spans roughly 92 billion light-years. When we aim our instruments toward that farthest limit, we don't see stars or galaxies. Instead, the view dissolves into a faint, uniform glow, the cosmic microwave background. That radiation is the universe's oldest light, a relic from a time before stars even existed. And that's the key realization. Looking deeper into space means looking backward in time. Take the most distant galaxy Webb is confirmed, JWST-Z14-0. The light we're seeing left that galaxy when the universe was only about 290 million years old. But here's the strange part. Today, that galaxy is no longer within our observable reach. Space has expanded so much that any light it emits now will never arrive here. Whatever it has become, new stars, merged systems, something else entirely, we'll never know. Yet the universe doesn't stop at that boundary. Beyond our observable bubble, space continues, filled with countless stars and galaxies stretching far beyond what we can detect. That horizon isn't a universal limit, it's just ours. Observers elsewhere in the cosmos would see a completely different slice of reality. Now, according to the standard cosmological picture, everything we can observe, and everything beyond it, was once compressed into an unimaginably dense state roughly 14 billion years ago. That idea works neatly if the universe is finite. But what if it isn't? If space is infinite, and mounting evidence suggests it might be, then it was always infinite. In that case, the Big Bang didn't erupt from a single location, it happened everywhere at once. That would mean the earliest galaxies didn't form in some privileged corner of space. They emerged simultaneously across the entire cosmos, including regions forever hidden from us. Matter itself would have appeared universally, not locally. The ancient background glow we see in every direction would then be the first light released by matter throughout all of space, arriving uniformly from every angle. That's the story our theories tell us. But Webb is beginning to poke holes in it. When the telescope was designed, scientists expected it to reveal the universe's first stars and galaxies near the edge of visibility. Instead, it found something deeply unsettling: numerous bright objects that don't resemble early galaxies at all. Follow-up observations haven't brought clarity. They've brought confusion. In a recent peer-reviewed study, researchers identified 87 potential galaxies that may have existed just 200 to 400 million years after the Big Bang. The sheer number alone was shocking. Current models simply don't allow enough time for so many galaxies to form so quickly. One of the study's authors, astronomer Haojing Yan, put it bluntly: even if only a handful of these objects turn out to be real, the implications are enormous. Our understanding of early galaxy formation would need a serious overhaul. Then there's the imagery. One particular object stands out, a structure so unusual it defies everything we thought we knew. Typically, galaxies contain gas and dust swirling around their cores, feeding gradual star formation. Decades of observations show that, at best, only about 10% of that gas ever becomes stars. But Webb uncovered 3 ancient objects that break this rule entirely. Spectroscopic data reveals that every atom of available material in these systems has been converted into stars. 100% efficiency. According to existing physics, that shouldn't be possible. The discovery has left astronomers stunned and unsettled. How could such systems form so early? Why do they look nothing like what theory predicts? And how did they achieve something believed to be physically unattainable? Some researchers are now openly questioning whether these objects are galaxies at all. They may represent an entirely new class of cosmic structure, something we don't yet have a name for. And if they truly are galaxies, then the implications are far more severe. It would suggest that the Big Bang, as currently understood, cannot account for what we're seeing. The timeline simply doesn't work. For now, the truth is uncomfortable but honest. No one knows what these objects are. And that uncertainty, more than any single discovery, is what makes this moment in astronomy so extraordinary.